Welcome to week 1, Thursday of Level C Math. We're going to do a little review because people wanted to talk about the 10 exercises in the rounding section. That's where we ended last class. So I will go to the Lego minifig, which is the shape-shifting section. Everything we do about changing one number at a time. Rounding 10 exercises. Click there, and there are these. So I've put this one on the Jamboard. And there's a rectangular garden bed. I'll start just by drawing that. And it has 2.74 meters for the long side and 1.22 meters for the short side. And it says it wants us to estimate the sum of the sides. It doesn't tell us how to round. So where would you start with this problem? Somebody tell me what to do. I will be your scribe.
Can you make that screen bigger?
Can I make it bigger? I can't change this screen. I can make the font bigger. It's hard to read. Is that what you mean?
Yeah.
Yes. Okay. So let me get rid of that and make it bigger here. And then when I copy it, it will be bigger. Is that big enough?
Yes.
Okay. I can do it more if you need to. Okay. Where do I start with the problem?
You round.
Could take this 2.74. I could round it to 2.7, or I could round it to 3. Either is a reasonable thing to do. Whoever assigned this to me didn't seem to be very picky. Which one would you rather do?
3.
3. Okay, so this side is 3. And similarly, 1.22, we could round to 1.2, or we could just be at 1. And I assume we're consistent, so if we picked whole numbers the first time, we should match. When I find the perimeter, I know it is needless when our brain is doing well, but just in case we're tired or up for careless mistakes, I like to mark a corner so I know when I go around when to stop. Because sometimes when I'm tired or headachy, I will either double count one side or skip one. So this just lets me not skip any. So 3 and 1 and 3 and 1. And by then I've gone all the way around. And I add them all up. And I get 8. 8 what? What is my unit? I have to go back and read it. 8 meters. So far, so good. It's sort of a 3-part problem. Questions about this one before we move on to the next? All good? Okay, then I will grab number 9. So this picture looks exactly the same. We still have a number that we can round to 3 and a number that we can round to 1. Everyone okay with 3.048 being closer to 3 than 4 and 0.9144 being closer to 1 than 0?
Yes.
So it's still going to be true when I add things up that I will get 8 meters. Okay, so far so good. Now the interesting one, which garden bed will be closer to the actual sum, because both of these are wrong answers. We're estimating. We're just sort of getting a sense of about how big they are. We're not being precise. Without actually getting the calculator and doing it carefully with the decimals, how do we know which is closer to the real answer? Is it Ben's or is it Alicia's?
I don't know. I got that one wrong.
Well, tell me what you were thinking, and then we can figure it out from there.
Oh, I think I probably just guessed.
Well, guessing I can't.
If we're being honest.
If we want the sum to be closer, we want the change from what's really there to be small, right? So which one did we change things the most? About how much did we change the 2.74 or the 1.22 by? Let's ignore everything but, oops, the whole number, the ones, and also the 10th digit. So if we went 2.7 and made that into 3, if we went 1.2-ish and made that into 1, then these are 2 or 3 tenths different. Oops, 3. If I look at Ben's, there's a 3.0-ish and a 0.9-ish. So if we take 3.0-ish and make it into 3, or if we take 0.9-ish and make it into 1, then that's 1/10 or less of changing. If that's harder to see in your head, you can always just subtract and see how big a difference it is. So this one, it changed 2 or 3 tenths. This one, it only changed by 1/10 or maybe even less. So Ben's is going to be closer. Questions about that now that you've seen it? Okay, thank you very much for your question. So in chat, somebody suggested Alicia's changed the most. Yes, Ben's was less, hers was more. Okay, anything else about all the stuff we did not yesterday, Tuesday? We did so much stuff.
Would I be able to look over this stuff in the email you sent?
Yes, and let me show you right now where to go, just in case you ever don't find the emails. So at the top of all of these pages, there's this menu. Here's a good review if anyone wasn't here on Tuesday. The welcome page gets you to like the main thing. The Zoom room is where you are now, so I know you know that link. The Jamboard is if you ever want to open a second window and look at this while we're in class. Otherwise, you just watch my screen. But sometimes people want to open a second window so they can browse at their leisure. This textbook is one that will be sending you a code, I hope. There's some grant that came in to get money. Hopefully you'll get a code. Without the code, you can only look at chapter 1. And as you go through the notes, and whenever you see brown numbers, then those are which textbook sections we're in at the moment.
Okay.
And at the end of each section, there's a pink box that says if you have a typical math background, you're only as rusty as the average student in this class, then this is probably enough homework from the textbook to make sure you're on top of things. So page 9, I can go right up here to 9. And then it says look at 13, 15, and so on. So if you want to do those, then there you go. The last bit is how do you know you got them right? Normally in a paper book, you would look in the back of the book for the answers. But in this one, you go to the supplements tab on the right, and then click selective answers there, and it will open the back of the book for you, so to speak. So you can see if you got the right answers.
Okay.
So where were we? So that was that. You can always see lectures here if you're a YouTube person. The Zoom is a little better because you can search the automated transcript text. So if you want to know just where I talked about estimating, you could search for the word estimating. YouTube doesn't let you do that, but YouTube is convenient for other reasons. And this link is a great calculator that I will use when we need a calculator. For now, I'm just going to hide it in another tab. These things you should look at later. The one I want to focus on to answer your question is the syllabus, the little blue box that in tiny letters says, keep calm, and look at the syllabus. And if you can't read the little blue box, then just look at where it says syllabus right here. These same 7 things are in this paragraph. Once you're at the syllabus, then each week we have a to-do list. So you click on the bar, like in Moodle, how they have these bars that fold out, right? And there's your to-do list. And underneath it is all the lectures. So here is the Jamboard we did on Tuesday. Everything is there. And then the videos, your choice. Do you want to click on the Zoom version or the YouTube version? So that's where to find things. So
Oh, perfect. Thank you.
Scroll down, unfold, and look in there. You're welcome. As long as I'm staring at this, it is always true that in a math class of 20 to 30 people, there's maybe 3 or 4 that do almost all of the asking questions. And everyone else gets to be lazy. And they have the same questions, but they don't have to ask them because these are the 3 or 4 people who do it for them. And if we were in a normal term meeting in a classroom, then I make several reminders throughout the term that if someone else is asking the questions, so you don't have to, they are doing your work for you. You should, buy them a coffee or something like that. The equivalent in a remote term with Zoom is turn on your camera some. It is really hard for the people who are being brave and asking questions to feel like they're all by themselves. So maybe you're eating dinner right now, 6 o'clock to 6:30 is not the time to show your face, but maybe at 6:30 or 6:45 we can see you or something like that. So at least some of class, let us see your face. It's mostly so that the people that are being brave and asking the questions so you don't have to, don't feel like they are just being interrogated by the instructor in a dark room, just them. So thank you for those of you who have your cameras on. And if you don't own a camera, then I understand. Okay, where were we? We were going, so our math topics are here. The first one is this shape shifting. We talked about rounding, decimal accuracy, and estimating. Go look at the record from Tuesday if you missed that or just want to see it more. And we had questions on these 10 exercises just now. So they don't have a due date. If we don't have questions on Tuesday, then they will be due the next class. So these will probably wind up being due Thursday next week because Tuesday of next week there won't be questions. But if people do have questions, it will push them back further. Remember how you turn these in is you go to the link above the 10 exercises of this form, and it's the same things, but you have to click all the bubbles. And then when you get to the bottom, it makes a code. copy and paste that and send it to me in an email or a text.
Great information.
You're welcome. Then it takes me just a quick time to grade it, and you can try it until you get 8 out of 10, as opposed to only one try, because I have to grade everything and it takes forever. If you want more problems, you've seen two kinds of problems in the textbook and the 10 exercises you turn in. If you want even more, then there's random exercises. So every time you load the page, the numbers change and they have answers. So you can get as much practice as you want. And the things that will actually be on the tests are these. So if you're trying to move up to level D or a different math class for credit, and you need a good test score, then there you go, practice that. Okay, great quick review. Anything else about how the class works before we talk about fraction format?
You answered it all for me.
Okay. So we won't do too much with fractions. Remember that we're just doing the shape-shifting things with one number at a time. When we get to mad science expressions, then we'll actually add and subtract and multiply and divide fractions. But we're not there yet. We're just looking at fractions all by themselves, just one fraction. And we're actually not even going to start by talking about fractions. We're going to talk about division. And unfortunately, I have to say more than I would like, because most people, through zero fault of their own, are only taught one way to think about division, and this causes people to get stuck. So I'm going to teach you both ways to think about division. And if you had a great math teacher in your personal past, then all of this will be review. If you are like most people, then a little of this will be review, and some of this will not be review. And you'll go, how come no one taught me this before? That would have made it easier. Ready to start?
Yep.
Okay, so we're going to start by thinking about dealing out cards. And I should probably put my header in there also, right? Be good. So if I have some cards, oh, okay. I think I actually want, nope. I want that. Okay, so let's make 6 of these cards. I want to model 6 divided by 3 equals 2. And we all know that 6 divided by 3 equals 2. The suspense isn't how to do 6 divided by 3, it's how to model it and think about it better. So I'm going to pretend that these 6 cards are in my hand, and I have 3 people. So here is my 3. So I'm having 3 people sitting around a card table or whatever this is. Thank you for not judging your math teacher by his artwork. Okay. Now I'm going to deal out the cards. We've all dealt out cards, right? You get a card, you get a card, you get a card. Keep going around the circle. Okay. The question I have is, what is my answer? What is this 2?
Each person gets 2 cards.
Yeah, each person gets 2 cards. This should seem like review. Everyone has taught this. Maybe you had a school teacher at one point that actually took out cards and dealt them out when you first learned about division. But this is what everyone is used to. Unfortunately, it doesn't do everything we want. If I try and do 6 divided by 1/2 equals 12, then something goes wrong. I still have my 6 cards. So how do I get started?
I believe that is 7 cards.
Did I paste wrong? I did. Okay. Thank you. So the number I'm dividing with, the divided by 3, now it's a divided by half. That's supposed to be how many people? I'm not sure what to do. Even if I had a friend sitting there and I chopped him in half with a samurai sword, I'm still not sure how to divide cards, how to deal out cards to half a person, right? Either I'm dealing them out to somebody or I'm not, regardless of how much I mangled them. So I'm kind of stuck. I'm not sure how to deal out to half. So we need a different thing to do. So what we're going to do instead is think about making piles of a fixed size. So I still need my 6 things. And now I'm going to pretend I'm antisocial and have no friends. I'm not going to draw little stick figures. I'm just going to say 1, 2, 3. That's one pile of 3. And then again, I take these out of my hand. 1, 2, 3. There's my second pile of 3. So what is the answer now? What does the 2 represent?
2 piles.
2 piles.
Oh,
So this is now the size of the piles. It's the opposite of what we just did, right? Before, where I wrote how many people, then I could say how many piles. Make it match here, how many piles. And over here, where I said each person gets 2 cards, I could say that's the piles, the size of the piles. So we've switched it. How many piles was first, size of the piles was second, but now size of the piles is the first one, and how many piles is the second one. And this one I can actually think about fractions. I can take my, let me start a new slide. I'm gonna crowd things if I don't. Okay. So if I have my 6 cards and I want to do 6 divided by 1/2, now I can do that. I take my card and I make a pile of size 1/2, because now the number after the division sign is how big the piles are. How do I make a pile of size 1/2 with this card?
I'm stuck.
You're just not violent enough. We rip it in half.
Oh, God.
Doing this in class, I would actually have an index card and rip it in half. So we're going to take that first card and rip it in half. And actually, we're going to take all the cards, oops, and rip them in half. Okay, so I'll get rid of these. So I have 12 pieces here because I've ripped all the cards in half. So here's one pile, there's one pile, there's one pile, and so on. All I'm doing is spreading them out, right? But I will label this and it will magically look nice. So this is 12 piles of size 1/2. You might have heard that dividing by 0 is like infinity. The answer isn't actually infinity, it just behaves like infinity, but that's a different math class. So why is this true? If I do 6 divided by 0, I have the 6 things in my hand, and I put none of them in a pile, size 0. And again, I don't put any down. And I can just keep not putting them down all day. I never run out of my 6 if my piles are 0. It just would go on forever. So you can think about division easier if you're making piles of a fixed size. So that's the moral of the story so far. Ready to keep going? Questions about what we've done?
Just taking it in.
Oh, okay. If this is brand new, then it might just take more than once, just like you don't learn to ride a bike or do pottery the very first time. So the video will be. Okay, let's do some of these. For some people, the little pictures are terrible. They're just not a picture kind of person. When I draw these pictures of the rectangles, it just makes it more confusing. So if you know how to do fraction division and you don't like the pictures, that's fine. No one will require you to draw pictures. And if you don't know how to do fraction division without pictures, we will get to that at the beginning of the mad science topic. So all is good. But a bunch of people, the pictures help. So this is for them. And if that's not you, then just be patient, bear with us. You will have your no picture day eventually. Okay, so 8 divided by 4. I want to take 8 things, and I could do it either way. Should I deal out cards to 4 people, or should I make piles of size 4? Which makes more sense in your brain?
The first one?
The first one. Okay, so I will say 1, 2, 3, 4, 5, 6, 7, 8. The answer is going to be 2 because each pile had 2. What about
Yes.
8 divided by a quarter?
Can't be in there.
I could take 8 cards and deal them out to a quarter of a person. I'm not sure that means anything. Or I could take 8 cards, rip them up into quarters, and make piles that each pile is just one of those quarters. I think I have to do the second one. So there's my kind of ragged quarters. 1, 2, 3, 4 so far. And then this card I'm going to rip into 4 pieces. And this card I'm going to rip into 4 pieces. And this card I'm going to rip into 4 pieces. And I'm going to do it again, but be lazy and not draw it. Okay, so how many pieces did we get overall?
$32.
32, perfect. If you are moving on to the next math class, just a heads up, at the end of this term, there will be a no calculator part of the test and a calculators are okay. That's most of the test. No one is going to ask you, I shouldn't say that, probably no one will care if you can do 8 divided by a quarter without the calculator. But you should know today that you could, right? You could understand that this is how many piles of a quarter am I making? And I get 32 of them. I didn't need a calculator to do. But if you have more important things to put in your brain, that's great too. Okay, 1/2 times 2. We just talked about division a lot. I'm just seeing if you're awake.
There. It's there.
I have a half of something. I have the other half of the thing. I put them together.
You have 1.
Just get one thing, right? That's just what 1/2 means. It's the thing that when you have 2 of them, you get the whole. Okay, now back to what we were talking about. 1/2 divided by 2. So I only have half of something. And I want to try and make piles of size 2. I'm not going to be able to make a whole pile. I just have a bit. Let's draw what that pile would look like. It would look like 2 things. But all that I have is half of one thing. So how many things would I really need to make that work? I need the half I have, another one there, another one there, and another one there. So I would get only a quarter. Oops, and I'm drawing a half of what I need to get a size 2 using halves. And if that goes over your head, that's okay. That one was really complicated. If that one makes sense, great. You're certainly on top of things. Okay, what's 1 divided by a quarter? So now I have a whole thing, and I want to make piles of size 1/4. This is just like B, but easier. So I take my one thing, I need to make piles of size a quarter. So what's my first violent step?
Cut it into quarters.
Cut it up into quarters and get out my scissors or rip it or whatever. So each of those is going to be one pile. 1, 2, 3, 4. I have 4 piles I make because each quarter counts. And last but not least, if I have a half and divide it by a quarter, this is almost the same thing. I have just half of my thing. I want piles of size a quarter. I don't have the other half of my thing. So how many quarters will I get? Only that one and that one. I don't have the other two. If you're close to getting this, but not quite, then I would grab some scraps of scratch paper that you're going to recycle anyway and watch the video again later on and actually rip things up and make piles in front of you. If you don't care about this, if the pictures again are not what helps your brain, that's great. You can always do this with a calculator. If I have a calculator like the one I showed you before, it has a key on it. That maybe no one has told you about. And it looks like either A, B over C, or maybe on your calculator, it just looks like A over B. In any case, that's to enter a fraction. And you press the key where the fraction bar happens. If you're using the Desmos calculator, the link from the top of the web page, whenever you do division, it's going to try and make a fraction out of it, even if you don't want it. So if I want to do one of these, like 8 divided by 1/4, I can just type in 8 divided by, it's going to try and do that again. And then 1/4, and I get 32. Do I even need that parentheses? No, I don't. If you have a calculator, it'll probably look more like what you want, where it says the division symbol for one of these instead of just double fraction bars. That looks a little too much like a totem pole. So use your A, B over C key or A over B key if you want to do that. And try that. See if 8 divided by 1/4, you can get to 32. There's too many different phone apps for calculators. I'm not going to try and predict what your phone app looks like. But if you have a good calculator phone app, it can do all of these for you. So you don't have to do it by hand. Okay, let's keep going. We don't care too much about this. We want everyone to feel confident that something like 8 divided by quarters isn't just some mysterious task that weird math people make you do. It really does mean that I had 8 things and I ripped them up into quarters and then I counted them. We also want you to know that if drawing this picture isn't great for your brain, that's fine. There's a nice routine way to do this we'll get to fairly soon. But we want to understand division so we can talk about fractions, because fractions are a lot like division. Okay, before we go on to fractions, almost, or divisibility, let's do these, because these are important. There are shortcuts for ones and zeros and hundreds. Let's go over those just in case people are rusty. What's times 1 for a number due to our 28?
$28.
It's just 28, yeah. One copy of 28 is 28. How about divided by 1?
Same.
It's also the same, it doesn't change it. Let's check with both ways. If I have 28 cards and I deal them out to my friend, all I'm doing is handing my friend a stack of cards. They get all 28. Or if I have 28 cards and I want to make piles of size 1, how many piles will I make? I will make 28 piles. I'm just spreading out my cards on the table to fill up space. So yeah, it's 28 no matter which way. How about the shortcuts for times 0?
0.
It is 0. If I have no copies of 72, I don't have anything. Just like if I have no copies of any number, I don't have anything. How about 72 divided by 0? That one we mentioned, it's sort of infinity. Mathematicians are actually really picky about what they mean by infinity, but just for casual life, then you can call it infinity and no one who's not a mathematician would ever care. If I try and make piles of size 0, I can do that forever. I never use up any of the 72 cards in my hand. Okay, how about taking a number and multiplying it by itself?
You use the 1 and add all the zeros.
Yes, this is a 1 because 1 times 1 is 1. We have 1, 2, 3, 4 zeros.
1,000.
And let's put a comma in the right.
Oh, 10,000.
How about some number divided by itself?
1.
That's always 1. So multiply by itself could be anything, depends on what we start with. But dividing by itself is always 1. And let's check with both ways of thinking about division. I have 100 cards. I deal them out to 100 people. Everyone gets 1, and then we're done. Right? I'm just passing out tickets or something, who knows? Or the other way, I have 100 things. I make piles of size 100. All I did was set them on the table instead of holding them in my hand. I just made that one pile. Questions about these? Okay. As always, at the end of a subtopic, you have some extra videos. Remember that in the textbook, every example problem you get to has a practice example and a video where you can watch people doing this, including in Spanish. So the textbook is a great source of videos, but if there's ever more that you want, then there's always some videos in the website. Oops, there we go. And then we have the textbook problems, although right now only the section ones you can get.
Thank you.
Okay, moving on. So factors are the next thing to talk about. And just like thinking about division, some people were taught this incompletely, not their fault at all. So let's do it right. And this actually gets practical. So if all of this, who cares? But this is what's actually going to help you doing the problems later. So factors are the numbers you multiply to get to another number. 3 and 5, as an example, are 2 factors of 15 because 3 times 5 is 15. Or 1 and 15 are also factors of 15 because 1 times 15 is also 15. And a lot of people
I'm in class.
thinking of factors as the edges of a rectangle. What are the factors of 12? I could do in the red one long line, 1 by 12. I could do a rectangle with the green numbers, 2 times 6. I could do a rectangle with the blue numbers, 4 times 3, and that's all the rectangles that make 12. So those are all the different factors. Notice that 1 and itself always work. No matter what I give you, you could always take that many coins and make a long caterpillar. So let's just make sure we understand what are the two factors of 5.
1 and 5.
1 and 5, that's all there is. You might know the fancy word. It's a prime number if the only factors are itself and 1. How about 25? There's 1 and 25, because those always work. What else is there? What's the third one?
5.
5. And that one I put on the page. 5 appears twice in the equation. 5 times 5 is 25. But when we're naming the factors, we don't have to say 5 twice. Just 5 is a factor. How about 6?
1, 2, 3, and 6.
1, 2, 3, and 6. If I was to put that on the board, actually get a title here. And I'm going to write them in a slightly different order. We have 1 times 6 is 6, and we also have 2 times 3. So some people like seeing the pairs. If I just listed them, that's not wrong. But I wouldn't feel comfortable as the person doing the lecture to not also have them this way. Okay. So we want shortcuts. Why do we want shortcuts? Because eventually we want to reduce fractions. So we don't want to have to think about it. Is 6 a factor of 96? Eventually you could figure out, yeah, 6 and 16 go together to make 96. If you were my son in 4th grade, he would call these fact families or something like that, because that's what his school used. So we're going to have shortcuts. And the reason we have the shortcuts is because we don't want to have to memorize lots of fact families. So almost everyone, when they get to my math class, knows these ones, that a number is divisible by 2. 2 is a factor if it's even. In other words, if it ends in 0, 2, 4, 6, or 8. A number is divisible by 5 if the 1's digit, if it ends in 0 or 5. And a number is divisible by 10 if it ends in 0. So I can just write a number and people can say, oh, that one's divisible by 5 because it has a 5 right there. Or I could write another number and they can say, ah, that one is divisible by 2 because it ends in a 6, which is an even number, and so on. If you haven't been taught these before, then holler in chat or find me after class or something like that. But I'm assuming that these 3 are okay. 25 and 26 aren't divisible by 10. They don't have a 0 in the 1's digit. So there are some other shortcuts that aren't any harder, but for some reason, most people aren't taught them. So a number is divisible by 3 if the sum of its digits, I have to sort of treat 2 and 5 not as 20 and 5, which they really are, but just as 2 plus 5 is 7. If I'm going to add them up, 3 goes into that. A number is divisible by 6 if 2 works and 3 works, because 2 times 3 is 6. A number is divisible by 4 if I peel off just the tens and ones, sorry, that's tens and ones, and 4 goes into that also. And a number is divisible by 9 if when I add up its digits, then 9 works. So let's copy both of these to a new slide, make them slightly smaller, and grab a big number, and we'll see how powerful these are. Actually, I want that one at the top. And I don't really care about that. Come on, finish pasting. You can do it. No, I'll try again. Okay. So is 13,512 even?
Yes.
Yes. So I look at the last digit. It's a 2, so that works. Is it divisible by 5?
No.
No, same thing. The last digit's a 2. That's not a 0 or a 5. Is it divisible by 10?
No.
No, because I look at the last digit, the one, it's not a 0. Okay, now we have to do something a little tricky. We're going to add up these numbers as if it's only just plain numbers. We know this 1 isn't really a 1, it's a 10,000, but we're pretending it's just a 1. It's kind of funky. So what do I get when I add those up? 4, 9, 10, 11, 12. Okay, so I'll look at that 12. Is that sum of digits divisible by 3? Does 3 go into 12?
Yes.
Yes.
Yeah. 3 times 4 is 12. So 3 goes into this big thing also. I don't need to do anything with a calculator or a terrible long division problem. I know that 3 works. Does 6 work? For 6, we checked. Did 2 work? Did 3 work? Yes, they both worked. That was here, whoops, here and here. So yes, 6 works. That's kind of neat. I don't have to do any long division or pull out a calculator. I know that 6 is a factor of this. Okay, for divisibility by 4, I'm going to just peel off the last 2 digits. So this is just the 12. And it's not the 12 from here. It's that I just peeled off the 1s and 10s. Okay, does 4 go into that?
Yeah.
Yeah, so 4 is going to go into the original number also. And lastly, if I look at the sum, does 9 go into 12?
No.
No.
So 9 is not going to work for my other number. So if you want to practice with these more, there's a bunch more example problems. You can check and see all the answers are here. We're never in this class going to actually care about numbers as giant as these. We're going to use this to reduce fractions that have more reasonable numbers as their numerator and denominator. But it's kind of fun to know that these shortcuts work just as well on giant numbers as they do on the smaller numbers that we will care about. If your multiplication table is rusty, which it often happens it is, then the fun way to practice your multiplication facts, or if you have a kid at home who is learning multiplication facts for the first time, is the factor game. So I need some people to be on the X team and some people to be on the O team. And how this works is that the first team is going to pick any number they want. Maybe they're greedy and pick a big number like 25. Then the other team gets to respond. They reply by claiming all the numbers that aren't claimed yet. There are factors of 25, so they would get 1 and 5. And that's one turn. It's like a call and response game. Now, whoops, I should make the greens the O's or it'll look really confusing. So now the green O team gets to start the next turn. They get to pick any number they want. Maybe they pick 16. And then on that turn, it's the blue X's that get to respond. So what are the unclaimed factors of 16 that the X's would get?
8.
8.
2.
2.
4.
4. At the end of the game, you add up all the numbers that you've covered. So blue would get 2 plus 4 plus 8 plus 25 and a bunch of other stuff. And that would be their score. So it's not just how many squares you have an X or an O in, but it's the actual numbers that you're claiming that count for points. So 25 was a pretty good play. The other team only got 1 and 5. They gained 19 points compared to their opponents. Whereas 16 wasn't so good. Yes, the green team got 16 points, but then the blue team got 8 and 2 and 4 is 14 points. They got almost as many. So let's erase all this now that you know the rules. And who wants to be the leader of the blue team and win fame and glory?
I will.
Yeah, okay, Sequoia. So if you like the color blue, if you think Sequoia is a good team leader, join her blue team. And who wants to be the leader of the green team? I think I should pick Emily or Sarah if they're being quietest so far. Sequoia was good in participating. Emily, Sarah, one of you be brave.
I will.
Okay, so if you like green, if you think Emily is a great leader, then you can be the O's with Emily. And team leader just means if everyone else is quiet or if they can't agree, you get the veto power. You get to decide what number to do on your turn. Okay, so let's start. Blue goes first. So Sequoia and her teammates, you get your complete choice, any number on the board, and then the O's will get the factors of it.
30.
30. So she picks 30. Okay, O's, help Emily. What scores do you get? If you forget an 8, too bad on you. So get them all.
10.
10. 10 is a factor of 30.
3.
3.
15.
5.
5.
I think someone said 15 too.
15 is a factor of 35. We don't have the other one that goes with it yet. 15, we don't have the other one. So there's more out there.
2.
2 matches with 15.
6.
6. Any others, or are you done?
1.
1. Yeah. Oh, okay, now you're done. Okay, now Emily, it's your team's turn to start, because so far all you've done is reply to Sequoia's 30. So pick any number that's not picked yet.
22.
22. Okay, blue team, help Sequoia. What factors of 22 do you get?
11.
11. 11 goes with 2, but 2 is claimed already. And then 22 times 1, but 1 is claimed already. So that's it. But that's okay. You got half as many points as the green team did. And now it's the blue team's turn to start.
$24.
24. Okay, green team, what do you get as factors of 24 that aren't claimed yet? A bunch of them, like 6, are claimed already. So
Can anybody answer?
Yeah,
I'm a little confused.
sure, anyone can answer.
4.
4. Yes,
Wait.
6 times 4 is 24. Anything
8.
else? 8. 8 times 3 is 24.
12.
12. 12 times 2 is 24. And that's all. Okay, green, your turn to start because you were just replying.
20.
20. Okay, X, blue X's. Do you get any factors of 20? One times 20 is done. 2 times 10 is done. 4 times 5 is done. I think you're out of luck.
Mhm.
But it is blue X's turn to just start now.
21.
21. Okay, green O's. Do you get any factors of 21?
7.
7. 7 times 3 is 21. And that's all. Okay, green's turn to be a starting.
27.
27. Okay, blue X's. Do you have any factors of 27?
9.
9. You found it. 9 times 3 is 27. And now it's the blue X's turn to start with their own number.
$28.
28. Okay, what do green O's get in reply?
14.
14, because 2 times 14 is 28. There's also 7 times 4, but those are claimed already. And 1 times 28, those are claimed. Okay, do you want to finish or should we just say you get the idea?
Okay, we call it.
Okay, so there you go, the factor game. If you want to review your multiplication tables, or if you have a kid that needs to learn them, more fun than just trying to chant out and memorize them. If you liked that, here's a challenge problem. see what the best move for Xavier with X's and Odette with O's would be. But finally, we're getting closer to fractions. Not quite. There are two flavors of factor finding. Sometimes we want to find all the factors, and sometimes we want to list out the prime factors. So this is so important that even though it's not really something to do, I'm going to put it on the Jamboard. This is also something that, following our theme for today, some people, many people, maybe most people, were taught incorrectly. If you were taught one of these but not both, that's not your fault. We'll catch you up now. So finding all the factors. If I want to find all the factors, then I make a list. I'm going to keep that small because I don't care if you can read it. I want to just find all the factors of 66. That one should be legible. So how this works is I'm going to make like a horseshoe. I'm asking myself as I count, does one work? Sure, one works with 66. Does two work?
Yes.
Yes,
33?
two works with 33. Does three work?
Yes.
Yes, three works with 22. Does four work? No, four doesn't work. Does five work?
No.
No. And this is where these divisibility rules, the shortcuts, came in, right? So this doesn't end in five, five doesn't work. Six work? Yes.
Yes.
Yeah, three work, six has to work. Some of these we don't have shortcuts. Does seven work? It doesn't. If you weren't sure, you could try it on the calculator or long division. Does eight work? No, four didn't, eight can't. Does nine work? Add them up. 6 and 6 is 12. Does 9 go into 12?
No.
No, so 9 doesn't work. Does 10 work? No, it doesn't
No.
end in 0. And now my horseshoe is done. I got to 10. If there was anything bigger than 10 that worked, it would need a small number to match up. It would be here already.
It would need what? Can you repeat that again? It was a little
Sure.
hard to hear you.
Sure, I'm happy to. So we counted down, right? 7 didn't work, 8, 9, 10 didn't work, and then we can stop. The horseshoe is done. If anything was bigger than 10, it would need a small number to match up with. It would have to be here already. We're not going to get something funky like 18, because if 18 was a factor, it would need a small thing to pair up with. So that's the process for finding all the factors. So if we want to reduce a fraction, that's handy. If we have 66 over something or something over 66 as a fraction, now I know I could divide top and bottom by 2 or 3 or 6 or 11 or 22 or 33 or 66. Probably I'd pick one of these small ones, right? But these are my options for how to reduce a fraction if the top or the bottom has 66. Assuming the other number in the fraction also had this. The other game is finding the prime factorization. This one has trees. So again, I'm going to make this small because I don't care. And I'm just going to have to write it on. I should update the website so it has matching problems. Find prime fraction of 66. So this is a totally different game. I'm taking my 6 and I'm saying it's something times something. I can actually pick any two of these I want. Anyone have a favorite? 2 times 33, 3 times 22, 6 times 11.
6 and 11.
6 and 11. Okay. And then I keep going. Can I break apart the 11? No. Can I break apart the 6? Sure. It's 2 and 3. Then when I'm done, I look at all the leaves and I list them in order. So 2 times 3 times 11. And that's a matter of politeness because someone else could have made a different tree. No matter how you do it, you're going to get the same leaves at the end of your tree. Everyone okay with what I mean by leaves, where the branches stop breaking up?
Yes.
And so if I'm working with Ruthie and we're comparing our papers, did we get the same answer? Then I don't want to have to juggle numbers in my head. Wait, 2, 11, 3. Right? So if she listed them out in order, then I can look at my answer in green and say, yeah, that's the same. So multiplying it turns out the same. 2 times 3 times 11 is the same as 3 times 11 times 2 is the same as 11 times, it doesn't matter what order you multiply them. But just to be polite, when you make a factor tree, when you find the prime factorization, put them in order. Makes your study group friends happy. That's useful when we're trying to find a common denominator for fractions. And that one we'll have to see in a little bit. It'll take us a few days before we get there. Okay, I'm going to make a line because I just kind of went over the halfway border. Okay, questions about that? I'm not going to worry too much about if you are good at this right now, because when we get to actually doing this with fractions, that's where the rubber meets the road and you'll get lots of practice. But if you want to practice, again, more example problems, you can look up a little bit and see we were section 2.3 in the textbook. You can keep going and here's more videos and textbook problems. And then eventually there'll be 10 exercises about this. This style of videos means you could click on the play to see the whole video, which I won't wait for it to load. You could click on the steps to see the steps, or you could click on the check my work to see just the answer. So, oh, okay. Okay, ready to keep going?
Yes.
Yeah.
So we have a lot of tools. Now we know about factors. We know about how to think about division. So we want to have desired denominators. So let me put that on the Jamboard. We want to be able to take one fraction, again, we're just doing one number at a time by itself right now, and change it so it has the denominator we want. Maybe it starts in halves and we want eighths. Maybe it starts in twelfths and we want thirds or something like that. So let's talk about what to do. And I'm going to use this picture of cake. You have to imagine this is a nice cake and not just ugly yellow rectangles. So if I take my cake that's thirds, can I make one cut so there's 6 equal pieces? Where do I cut it?
Down the middle.
Right down the middle sideways, right? Again, don't grade me on my own. Okay.
Shh, not right now.
So
No.
before we had 1/3. We had 3 pieces and one of them was shaded. So this was 1/3 to start with. But after we cut it, Now it looks different. Now it looks like we have 6 pieces and 2 of them are shaded. So if you care, again, some people like the pictures, some people don't. If you are unreducing, if I am taking the same number and multiplying the top of bottom of my fraction by this same number, all I'm doing is cutting my cake. My denominator is saying how many pieces did I have? And because each piece got cut into 2 smaller pieces, now I have twice as many. My numerator was saying how many were shaded. And each shaded thing also got cut into 2 smaller pieces, so there's twice as many shaded things also. Everyone okay with that?
Yes.
Okay, actually, I think I can fit 2 on the same board. So
Annalise, stop.
I'm trying to see the dog. I'm trying to see the dog.
I'm in class, baby.
I'm trying to see the dog.
okay, then let's do it again. Okay, so I still have my third to start with. La, la, la. And now I want to make 9. Before I wanted 6. Remember, the whole point is that there's a certain number that we desire for our denominators. So how will I turn this into ninths?
Cut it down the middle twice.
Cut it twice. Yeah. And again, please don't judge my artwork. Pretend these are all the same size. So the one piece that was shaded is now 3 shaded pieces. And the 3 big slices are now 9 little slices. We did a times 3 to the top and a times 3 to the bottom, and we got 3 ninths. So there we go. Maybe you thought this was boring and stupid, or maybe you love the pictures. Onward. So that is what I am going to call unreducing. And no one ever talks about unreducing. We always talk about reducing, but this is where to start with thinking about it. Unreducing. Reducing is going the other way. It would be if I take my eraser and somehow take my magic icing and glue my cake pieces together. I'm starting with the smaller cuts, and I'm somehow merging my pieces together and getting bigger pieces. Okay, so just for the sake of completeness, I will draw this. So I want to start with 2/6. I want to end up with thirds. So I'm going to say, oh, let's make some 6 and shade in 2 of them. That's my 2/6. But I'm somehow going to take my magic cake icing, get rid of that cut. And now I have 1/3, because everything that used to be 2 pieces, I've now clumped together. The other one, going backwards, I'm going to start with my 3/9, and I want to get thirds. So I will make my cake divided into 9ths. I will shade 3 of them. Now I am starting with 3/9, but I'm going to get rid of some of these with my magic icing. And now I just have one of the thirds that's shaded. Everything that used to be 3 pieces, I've clumped together. Okay, I don't want to stare at this too much because again, some people's brains don't like the pictures and I'm being mean to them. But if that helped you, great. So we get our definition. We reduce a fraction by dividing the numerator and the denominator by the same thing. We divide top and bottom by 2. We divide top and bottom by 3. We also say that a fraction is fully reduced if we can't do that anymore. There's no factor in common except 1. We've reduced it as much as we can. I will not use the word simplified. Many books and websites say a fully reduced fraction is simplified, but those same books and websites tend to use the word simplify too much, and just simplify sort of means make the teacher happy, right? Here's a math problem, simplify. It doesn't tell you what to do. So I'm not going to use that word yet. Okay, this is an important part. If I want to write reducing, there are right ways and wrong ways to do it. You don't want to either confuse your study partners, get things marked off when graded, or get in bad habits for later math classes. So if I want to say 2/6 is some number of thirds, there's several ways to write this. I could make first 2 floating little divided by 2's. I could say divided by 2 on the top, divided by 2 on the bottom, and that would get me 1/3. That's great. We like that, makes us smile. Everyone knows what's happening. It doesn't mean anything else. We are completely clear. What we can't do is write just 1 divided by 2 and have it sort of aimed in both places. That really would mean divided by 2 over 1, and there's this flip and multiply thing that if you don't know about it, we'll get to it soon. This is a different kind of problem. So we can't do that. That one makes us sad. Some people, instead of just having their divided by 2 sort of floating, like to do divided by 2 over 2. That's great. 2 over 2 is 1. Divided by 1 doesn't change anything. So if you like writing it that way, it's not as common, but there's nothing wrong with it. Go ahead. And then later on, we'll get to canceling fractions. Some people just love canceling. So they're going to write cancel slashes. 2 divided by 2 is 1. 6 divided by 2 is 3. And that's fine too. If you like it that way, go ahead. Okay, questions about these things?
Oh, good here.
Good here, okay. And this is also good to say. When you are reducing it's okay to take lots of steps. Being efficient is just being convenient. It is not a virtue. It doesn't make you a good or bad person or math person. So if I want to say 8 divided by 24, then I can use 3 steps. I can say let's divide top and bottom by 2. And that gets me to 4/12. And then I can divide top and bottom by 2 again. And that gets me to 2/6. And then I can divide top and bottom by 2 again. I get to 1/3, and now I am fully reduced, and I can put a box around my answer. Somebody else might say, I'm going to take 8/24 and just divide top and bottom by 8 and get all the way to the end.
1 and 3.
One step. And both of these are equally good answers. Okay, we do want to talk about this though. So let's put in a little bit of vocabulary. The one-step people, what makes their thing efficient is they've picked the biggest thing that fits into both the 8 and the 24. And so if they want to talk to each other and say, ha ha ha, we are the efficient crowd, they want to be able to have some jargon. So they use the phrase greatest common factor. And that's just the official words. We could say biggest factor, greatest thing in common, greatest shared factor, right? There's lots of English words we could use, but the math folks who did this first got to pick the official jargon, and they use greatest common factor. And all it means is the thing that's the biggest for both of them, so that we can get to our fully reduced answer right away. Okay, now you can be a snooty person and talk about that. We're at the end of a subtopic. So you have videos, you have some practice problems once the book code gets sent to you. We're covering a whole lot. Does anyone want me to go back and do more of anything, or should we keep plowing forward?
I think I'm good too.
Everyone okay?
Yes.
Yes.
Good.
Okay. Is the pace at the right pace? Do you want me to do more example problems of things as I'm going?
Your pictures actually helped me a lot, so I'm pretty good right now.
As I've said before, most people in my math classes, some of this through no fault of their own was never taught to them. So it's my job to finally teach it right. Okay, new topic, fractions and decimals. Our first thing we're going to talk about is decimals to fractions. So remember, we mentioned yesterday and at the top of the page that decimals have different names for the same decimal. If I wanted to talk about 0.5, if I was just sitting next to someone doing homework together, I would say 0.5, and I wouldn't write the 0 in front of it. That's like the casual name. This is what it wears to the beach, right? If I am lecturing, then I will say the dictation name. I'll say 0.5 and I'll write it as 0.5. And it's not better, it's just that saying the 0 point gives your ears this little split second of heads up decimal coming. Then there's the formal name, 5/10. We say the place value of the final digit. This one ends in tenths. So if I was in a court of law, if I'm doing some formal writing, then I will want to write out the words 5/10 rather than write it like 0.5 or 0.5. So if I know those things about the names of decimals, I already know how to turn a decimal into a fraction. So let's just make sure we know. What's the formal name for 0.08?
800ths.
800ths, because this is tenths and then hundredths. What's the dictation name for I just said it, for 45 hundredths? It would be 0.45. So to change a decimal into a fraction, we just say its formal name and then reduce it if possible. This is why we went over place value yesterday, not because I am especially loving place value, I just knew this was coming up. So 0.5 we did. Let's do actually 0.5 we didn't do, did we? We just changed its name. Okay. So 0.5, I will say it as 5/10. You would never actually write this out, but I'm lecturing. So how do I make 5/10 a fraction? It's 5/10. The last annoying part is the reduce if possible. Most things in math and physics are named after something, Fermat's theorem, Ohm's law, but whoever invented this rule that fraction answers don't count unless they're fully reduced, we don't know their name, right? Everyone is upset at them. They're hiding somewhere. I don't know who made this rule, but they made the rule, we have to follow it. So I will take my 5/10, divide top and bottom by 5, and I get 1/2. And you probably knew already that 0.5 was 1/2, but now you can kind of see it happen. Okay, someone lead me through this. 0.08. First tell me what to write as the formal name.
800ths.
800ths, exactly. By the way, I'm repeating what you say, not because you're not correct, just that I'm trusting my mic more than yours for the recording for people who aren't. Whoops, and I wrote the wrong thing, hundredths. Okay, so 800ths. I can divide top and bottom by 4. And get 2. What's 100 divided by 4? Think about quarters and dollars.
25.
25. And we're done. Okay, last one. What do I write first?
Hundred and 25 thousandths.
And again, if you weren't here yesterday and are confused about this, tenths, hundredths, thousandths. So we say the last place value name we got to 125 thousandths. Okay, anyway, so 125 thousandths. I want to think about money again. How many quarters go into $1.25?
5.
And how many quarters go into $10? You can cheat and use a calculator too, but $10. Each dollar has 4 quarters, so 10 would have
40.
yeah, she's saying it, but didn't.
It was 40.
We're not done. There's something in common, so we have to keep going. La la la.
1 ace.
1 8. Okay. If you have that fun recommended calculator, there is a button on it that says, it actually says I'm in the dark. You can't see it. It looks like change with a little arrows around it. So if you own that particular calculator, you can just put in 0.5 and hit change, and it will make the fraction for you. So you don't have to do this. If you have a different calculator, there's probably another button that does this. And I just don't know what it is because I don't know your calculator. But you can always meet me after class, hold your calculator up to the camera, and we can see what model it is and search online for the instruction manual and find the button. Okay, so far so good. You could turn more decimals into fractions if you needed to. Okay, I am going to take a, actually I'm not gonna take a break because it's almost 7:50. Let's just finish up. Okay, we did decimals to fractions. Guess what we're doing next?
Fractions to decimals.
Decimals, yeah, good segue. Okay. So, why is that one there? Oh, I know why that was there. Okay, anyway. Okay, there's a game if you wanted to play, but we will skip the game. And this one, I need to be rude and change, because otherwise it wraps funny. I have no idea what that looks like on your screen. Okay, to change a fraction into a decimal, then all we do is treat it as a division problem. We take 1/5 and we say that's the same as 1 divided by 5, top divided by bottom. If it helps you, then write top divided by bottom in your notes. Some people don't like the words numerator and denominator as much. So what is that? Take out your calculator, do it, you get 0.2. I'll take out my calculator and 1 divided by 5, and I get 0.2. Remember, this calculator likes to make things into fractions. 3/8, same thing. Would you actually write the fraction again? Probably not. You would just start right here, right? So 3 divided by 8, take out your calculator. 3 divided by 8, and I get 0.375. Have I been putting boxes around my answers? I have been, so I should keep it. So ta-da, we can go back and forth. Decimals to fractions, fractions to decimals. let's skim ahead, see what's coming up. Repeating decimals are something we should talk about briefly next time. And then we're done. We're at the videos, the problems with steps, and the textbook exercises. The last thing in this whole section of fractions is talking about ratios and rates. So now we know what we're doing Tuesday. Finishing up and then doing ratio and rates. And when I look at the 10 exercises, then some of this is ratios and rates, the last 3 problems, but the first 7, you're ready to do right now. So if you want to get ahead on the weekend because your weekdays are really busy with jobs and kids and stuff, I would do numbers 1 through 7 in these next 10 exercises. Let me actually grab them and put them on the Jamboard as a reminder, so that if people later can't remember quite where to go, then this is the first 7 of the 10 exercises. Oops. Is there, those 10 exercises, right? First 7. We are ready for. If the weekend is the wrong time to do homework, then you don't need to start these yet. You can wait till we do ratios and rates on Tuesday. Maybe you work on weekends and not as much during the week. Whatever the case, I would highly recommend going over the notes. We skipped over lots of example problems, remember. Make sure things stay in your brain, because otherwise they're just going to run away. That's how math works. It all makes sense when I'm dancing around at the board, and then as soon as you're by yourself, your brain is like, what? So, okay. The last thing I want is there's this little interlude. Am I in the right math class? I sent out an email that if you think this is all really easy, maybe it's because we're doing review, or maybe it's because you should be in the next class. So you can go right to our practice finals. These will change a little bit to fit math level C as opposed to math 20. Right now it says math 20, but they're almost the same content. But if all of these problems either look easy or just look like something with a few hours of YouTube or tutoring or something you could do, then you're probably ready to move on. If you can't do these, great, that's why you're here, right? So try a practice final if you are wondering, should you move up? If you're wondering if you're in too high a class, then in level B math, you're supposed to know how to do these things. Or if you're taking the similar thing, math 10, you would also need to do those. And as I say at the bottom of the interlude, we will review all of those skills. So if this review is making sense, when you try the homeworks or the 10 exercises, you're doing okay. Maybe not your first time, but second or third time turning in the codes, then you're doing great. You're learning the math, you have time management, study skills, is everything good. So if you are rusty, or if you haven't been taught things properly, that doesn't mean panic, you're in the wrong class. It means the review is what we're doing. On the other hand, if this has been really confusing, or if your reaction is it's impossible to make time, then that can be a concern. So talk to me. Maybe you should move down and not push yourself this term if the time management is the issue. And I wanted to share one thing just because it was kind of fun and inspiring before I say we're officially done, and we'll do a little break and switch to the study session. We can either go over the problems we skipped over from example problems or jump right to those 10 exercises, the first 7, whatever you want. But I want to show you this final exam. Julie said I could use her name. There will be some semi-mythical Julie that goes down in math history. So she was in my class last term, and she was in a different class than yours. This is 105, but the predicament is what might be familiar to many of you, that she didn't officially meet the prerequisites. She met with me in Zoom before the term began and said, it's been too long since I've had math. I am more rusty. If I took the placement test, I wouldn't place into Math 105, but I have lots of time. I'm an older woman. I don't have kids hanging on me all the time anymore. I'm just working one job that has a nice regular schedule, and my boss isn't going to be mean and keep changing it. So I can really put in the hours. And she turned in a 25-page final exam. The way she worked, she not only made notes about how to do things in her notes, but every time she did a practice test or the real test, then she wrote out the steps and explaining how the steps work. And she had so much time that she aced her final and got 100%, even though she officially shouldn't have been in the class. So the moral of the story is, if you are like Julie and have the time, don't worry too much about your prerequisites. I had another student last term who started very strong, but then there was the snows and the power outage in Portland, if you remember those. And she spent the second half of the term taking care of her elderly relatives because they were old and Portland had no power. So she had to drive up to Portland and fetch them and bring them back to her house in Eugene and try and live with them in the small house and so on. So she wound up being very heroic. It was probably in important ways a more successful term for her than people who passed Math 105, but she didn't pass the class. She just couldn't get enough work done while taking care of her relatives. So if you don't have time, then that can doom you. So that was my little spiel. I don't want to be too scary, but I want to be scary enough. There was one term I taught Math 20, and a student turned in the final exam the last day. His attendance had been terrible. We both knew he was not going to pass the final, but he wanted to see how much he had learned. And he said, I guess this isn't the term I should have taken math when I was starting a new business and going through a divorce. And I said, yeah, I think that was just a little too much on your plate these 10 weeks. But, oh well, he tried, he did his best. So think about time management. Talk to me, talk to somebody else if you need to make a judgment call. But hopefully it's pretty clear. You have time for this or you don't. Any questions about that?
No.
No? Okay. I will also add the time is more efficient with a study group. Right? The reason I am so big on study groups is you just get the work done quicker, you learn more efficiently, you don't have to do as many problems to finish learning it. So study groups are great. They save time. And I know that they don't work for everybody. Some people just have schedules that it's kind of hard. But last term with a class that was more than 30, we had like 5 study groups going, Saturday morning, Saturday evening. I was in a study group with a bunch of students every Saturday at 9 at night, because that's when it worked, when the kids were in bed. So if you want more than our end of Thursday, end of Tuesday study groups, let me know. I can be in Zoom at other times and help you get work done. Okay, I'm going to pause, turn off the recording, turn on the lights in the house and close the blinds. And then I'll be back in a few minutes and we can do whatever you want with studying more, whether it's the 10 exercises or other things. So hang out, I will see you soon.